It's gonna be like that. Hi, my name is Sotiris. I'm gonna present you the paper we wrote with Daniel Hart and Dick Howie, and it's about news clicks prediction. So let's talk a little about how do we interact with news. I guess it's gonna be something like that. It's a Facebook post. And would you click on that? No, because you don't speak Danish, of course. But anyway, no, joking aside, what is it that attracts readers' clicks? And this is something the news editors over at Jyllands-Posten have been asking. And it's not so trivial to answer. So we looked at previous research in click detection, where the authors compared between just the headline or the whole article body. And they found that actually using the whole article body is achieves much higher accuracy. And isn't that a little paradoxical, since the readers just see the headline? So we hypothesized that readers actually anticipate an article's content just by reading the headline. I mean, there must be some information in the headline combined with some inductive kind of knowledge readers have that, at least in our experiments, it was difficult for deep models to capture. So we set out to find some ways to model this kind of knowledge, and we've particularly focused on three types of knowledge that humans we assume to have. Lexical knowledge, as in the semantic content of words and the other words each word relates to, and we model this by training some word embeddings on a much larger data set than our own news data set. We believe syntax is important because it gives the specific style of the author and can also include references to the article body, for example, through the use of pronouns. And we choose to model this using our first auxiliary task, part of speech tagging. Finally, we assume that readers are interested in specific topics, and if you read the headline, it's not that hard to understand which section of the newspaper comes from. So we do this in a topic modeling task, which we call section prediction, as we actually try to predict which section of the newspaper did this headline came from, like politics, sports, etc. And we use recurrent neural network architecture, of course, it's a no-brainer, but specifically some gated recurrent units. So our data consists of viewing logs from Jyllands-Posten, a major Danish newspaper, spanning from 2015 to 2017, almost close to about 82,000 headlines. And if you want it for research purposes, you can mail us and you will get it. And we extracted the median number of clicks. So we define a popular article if it's in the top 50% of click counts, thus making it a binary classification task. For the section, we extracted more than 200 sections from the article's URL, and as I wrote before, it's a kind of fine-grained topic modeling. And we also use some diverse Danish texts annotated with part of speech tags for part of speech tagging, plus a dump of Wikipedia, and combined all the data sets together for our embeddings using Word2Vec. So let's come to our gated recurrent unit architecture, which consists of, the basic building block is a bidirectional gated recurrent unit layer. We stack up 3 layers of these as to accommodate for the 2 auxiliary tasks we have. And it's a typical scenario, we feed the word embeddings, and in the uppermost layer we take the last output and pass it through a fully connected to get the prediction, is it in the top 50% or not. So we optimize the architecture, that is the hidden size, for just a popularity prediction task in a single task learning. And then we add the two auxiliary tasks and train sequentially on each epoch, starting with a lower task, like part of speech tagging, and ending with a popularity prediction. And also, in order for higher layers to be able to benefit from what lower layers have learned, we combine them with we feed the output of each layer to the next one's input using a fully connected layer. It worked better. So as baselines, we implemented 2 models similar to the previous research I mentioned, which is a logistic regression classifier with TF-IDF scores for unigram and bigram features, but we also had another non-deep architecture, character level this time, consisting of byte to hexagrams of characters. And for our gated recurrent unit architecture, we compare between randomly initialized embeddings, the pre-trained ones, and each of the two auxiliary tasks, and both of them combined. So we're going to present the averaged accuracy for the two classes, starting with our baseline models, which offers a huge improvement over previous work, but this is easily explicable by the fact that we have a much larger data set. But also another surprise was the character n-grams model that achieved even higher performance. And we offer a couple hypotheses of this. For example, better handling of out-of-vocabulary words and many more features. Now, the plain gated recurrent unit with randomly initialized embeddings actually was the worst of our models. And this, we think it points to the small data set we have. And yes, but adding the pre-trained embeddings on the much bigger corpus, we actually surpass the word-level models. Now on the multitask learning part, we notice that each task individually doesn't offer any improvement. And specifically the part of speech tagging, the results are actually worse. But adding both of them together, we can match the best non-deep model, which is the character n-grams. So, we believe click prediction performance can be boosted by multitask learning, as we demonstrated, compared to the single task, even with pre-trained embeddings. And we would also like to note that the n-character model is non-deep, but is not simple, because the vocabulary consists of over 800,000 unique n-grams, while, for example, the gated recurrent, the 3 layers, are about 300,000 parameters. And of course, we saw a clear advantage of subword features, and we hypothesized this could be because of better handling of out-of-vocabulary words. The model can still extract some information, some form of implicit lemmatization, as inevitably one of the n-grams is going to be the lemma. And of course, we're talking about the Danish language, which makes extensive use of compound nouns made out of 2 or more simple nouns. So, as a conclusion, we would like to stress the importance of non-deep models, especially when we having new tasks and new data sets that don't appear in previous work. And also we saw the sensitivity of the architecture in choosing the right auxiliary tasks, and this is something that aligns with previous research, but at least in our case it had to be empirically determined. And of course, the importance of subword features. And for future work, we would like to see some neural model with multitask learning and subword features. We already been experimenting with byte pair encoding, and we got some very promising results demonstrating the same pattern. And we'd like to try some other languages in order to check if this subword boost is just language dependent. And finally, of course, some more data, because one could claim that given enough data, the model will learn itself the features needed for the task. That's all. Thanks, and I would be happy to answer any questions.
Any questions?
From the example you showed, it had an image. So I was wondering, with these headlines that you collected and you had the click data for, did all these headlines have images, and where the readers could infer meaning from the image itself? And also, you have to take account some way, or did you think about taking account some way where these were placed on a page? I imagine like if something's placed at the top of a page of the news website, it's going to get clicked more if it's at the bottom. So you can't just infer that based on the text. So these things.
Yeah, that's a really good comment. Because actually newspapers also choose the placement of their articles depending on what is popular now. But the clicks actually are aggregated, and they include like also Facebook referrals, Google referrals, Reddit, other popular newspapers. Most of them are from the newspaper's website though. But we assume that the effect kind of gets cancelled because we have actually aggregated all together. So they might appear on top, but also they might appear on the side or on your Facebook feed.
Hi, I have a question about topic modeling. I'm here. So you mentioned you included topic modeling in your model. Is this part of the current model, or you've done it externally and then you incorporated it? Can you explain how you did it, please?
It was the same data set. We have the advantage that because its headline has a URL, so the new site already had the topic in the URL. So we could train on the same data set simultaneously. But instead we trained each epoch. So we trained some samples on part of speech tagging, then some samples on section topic modeling, and then final the popularity prediction with each cycle repeating on each epoch. So it was kind of trained simultaneously, but no.
Hello?
It has to be short. Yes. It's short question only. Yeah. Just go ahead.
Yeah, sure. So, this social media headline prediction is about predicting something that is relatively new. So, how do you taking it into account you are taking into account the number of clicks, right? So that shouldn't be. Is it in making it biased towards some popularity, like some post?
Some previous research, they tried to also like making 4 bins instead of 2, just high and low. And we also tried regression. I don't have any concrete advice, and I think it's a good point that we need to investigate more into that.
And did you check your correlation, Spearman correlation ranking?
Yes, we did some preliminary analysis.
No, you have your scores as well in.
Between what?
In your paper that.
No. Thanks.